Welcome to the training module on the OSRAM reflective optical switch SFH774x. This training module will introduce the reflective optical switch SFH774x. The SFH7740 switch measures just a few millimeters, 3.7 by 3.7 by 1, and reacts to tiny distances between 0.5 and 4 millimeters. It is so small that it will even fit in a slider phone, where it detects the position of the slider that reveals or hides the keypad. This device was conceived to detect the position of mechanical parts. The contactless SMT sensors SFH7740 from OSRAM Optosemiconductor will enhance the convenience of mobile devices such as cell phones and digital cameras, and also save on battery power. The SFH7741 is a very small reflective optical sensor for short distances with digital output. With dimensions of only 3.7 by 3.7 by 1 millimeter and surface mount solder contacts, the device may be integrated in applications where reflective sensors have previously not been considered. This device was conceived to operate as a short to medium distance proximity sensor. The typical operating range is around 30 millimeters for a diffusely reflecting target with a high reflection coefficient. The tiny SFH7741 optical proximity switch reacts at distances of 1.5 centimeters to around 5 centimeters and is suitable for a wide range of applications. It detects when the phone is moved close to the ear, taking the display and keypad out of sight of the user. This page gives features and applications of the SFH7743 device. Its typical working distance with external emitter SFH4650 is 40 millimeters. It has an opto-hybrid Schmidt trigger output open drain and is extremely low power consuming with very small SMD package. It has high ambient light suppression. The SFH7740 and SFH7741 sensors are active devices, unlike the Hall effect sensors mentioned in the company's press release. As pulse devices, reflected signals are measured internally every 90 milliseconds, and the device output is then readjusted accordingly. LED-on time is as short as 44 microseconds with about 90 milliseconds of off time, which contributes to low power dissipation. As 3-volt opto-hybrids equipped with onboard Schmidt trigger outputs, these low-power devices provide open-drain FET output stages for driving external circuits. A programming resistor, a few power supply line bypass capacitors, and a pull-up resistor for the output FET is all that is required on the electrical front. The SFH7740 and SFH7741 emitters peak at 850 nanometers, and the sensor's elements exhibit maximum sensitivity to light at 880 nanometers. However, the internal phototransistors have a broader response than that of the emitters. OSRAM's EMI R5 resistant parts typically draw only about 45 microamps, which is reasonable for devices designed into a battery-powered product. Hall devices require current-hungry conditioning circuits. Optical response is rated from 730 nanometers to 1080 nanometers. When the supply voltage reaches VDD start, the sensor output stays low for 60 milliseconds to 120 milliseconds. Subsequently, approximately every 90 milliseconds, the reflective signal is measured and the output is set accordingly. The part consists of an infrared light-emitting diode with a wavelength of 850 nanometers, a phototransistor, and an ASIC. A block schematic diagram is shown here. For low power consumption, 45 microamps average at VDD equals 3 volt, and R programmer is equal to 470 ohms. The ASIC performs a measurement every 90 milliseconds, and the result is latched at the output and held until the next measurement result is present. When the measurement is performed, the emitter is driven with current for 44 microseconds. The phototransistor current IP is measured twice. The difference between the two measurements is compared with an internal threshold setting, and the output is set to the appropriate digital level. This page shows a block diagram of the SFH774x. The external emitter can be driven directly with 10 milliamps to 60 milliamps in pulsed mode. This means that any series resistance on the VDD line causes a voltage drop at the power in pin. The IR emitter pulse is a high short load for the power supply. In any reflective optical sensor, the detector receives light not only from the desired target. Ambient light as well as reflections from other objects such as frames or covers contribute to the detector signal. In most applications, the sensor may be placed behind an IR transparent window. The detector signal comprises signal portions from light reflected by the detective object, the ambient light, and crosstalk due to the cover window, frames, or other objects in the vicinity. The part consists of an invisible infrared light emitting diode with a wavelength of 850 nanometers, a phototransistor, and an ASIC. Target position is detected by measuring the amount of light reflected from different areas. The ASIC performs a measurement every 90 milliseconds, and the result is latched at the output. The device is designed to provide an operating range of approximately 0.6 to 1.4 millimeters, assuming the preset emitter current at 10 milliamps, and a target that reflects diffusively with a reflection coefficient of 90%.